In chemical bonding chapter, there are four important topics are there. One is Lewis dot structure. Lewis dot structure. Then another one is hybridization. Hybridization. Then another one is bond order and magnetic properties. Then another one is shapes of the orbitals. Orbitals. These are the four very important topics. Generally, they're asking the question either Lewis dot structure or hybridization. These four only maximum cases they're asking only these four chapters. And here also one more is there, that is a dipole moment. Dipole moment. These are the very important topics. The remaining all topics are just once revise and deliver. But these are the have to focus the maximum focus. These are the topics. Now we have to find out that how it is formed the covalent bond. So how it is formed the covalent bond? The covalent bond always sharing of electrons. So here sharing of electrons. So for example, hydrogen molecule, how it is from the hydrogen molecule? So here hydrogen molecule, first we have to take hydrogen, that is atomic number is 1, electronic configuration is 1s1. So here I will write here 1 electron here. So another hydrogen electron here. These two, if from the bond means it should be both are it from first it from the hydrogen S, again one more S. So finally from S, then here also S. So here these are the 1 electron here, these are the 1 electron here. Finally from this electron and this electron from F1. This is we are calling as a sigma bond. This is we are calling as a sigma bond. For example, they are asking the question, then how it is from the CO2. So how it is formed? First, you have to first find out the central element. So less electronegative element is a central element. Is a central element. Less electronegative element here. Element, central element. So here less electronegative is element is carbon. So that the carbon is a central element. So carbon atomic number is a 6. Electronic configuration is 1s2, 2s2, 2p2. So always we have to take excited state. Last two shells we are calling as a excited state. Here s orbital, this is a 2 electrons. And again s orbital 2 electrons. Then here p orbital also having the 2 electrons. Here 1 electron, 1 electron. Again in excited state, excited state. Here this electron jump to here. Then here this is a 1. Here 2s orbital is 1. Again 2p orbital is 1, 2, 3. So total how sorry here 2s is only 1. I'm very sorry. This one 2s is only 1. So here only 1 electron is present. Total unpaired electrons. How many? Unpaired electrons. Unpaired electrons are 4. So only unpaired electrons formation in the bond formation. Here carbon. Here how many unpaired electrons are there? 4 are there. 1, 2, 3, 4. Now we discuss about that oxygen. Here oxygen atomic number is 8. Electronic configuration is 1s2, 2s2, 2p4. So here this is we consider as an excited state, 2 electrons. Here 1, 2, 3, 4. So here what happened? Here these two are the unpaired electrons. Unpaired electrons. These electrons are bond formation, involving bond formation. So here, so we wrote here carbon. Anyway, carbon has 4 electrons. Again, each oxygen, how many electrons are there? 2 electrons. So here also oxygen 2 electrons. But here this electron and this electron form a new bond. Here, this electron. But here we wrote remaining these two always we are considered as a lone pairs. What are the lone pairs? How many? Two are there. So we wrote here one lone pair here, one lone pair. Always you have to write down pair is like this. Here one lone pair because of we consider only one oxygen, but CO2 means which has two oxygens. So two lone pairs. Then we wrote final structure is a C double bond O, then double bond O, double bond O. Then remaining are electrons. Lone pairs are this one. So this is we are calling as a linear structure. I will tell you then what are the shapes in previous next class. This is a formation of sigma. Now we have to find out which one is a sigma bond, which one is a pi bond. The always bottom these two are the sigma bonds. Sigma bonds are two. These are above always from the pi bonds. Pi bonds are two. So if it is only sigma bond is there, that is a that only one single bond is there, that is a sigma. If it is a multiple bond are there, one is a sigma, remaining all are pi bonds. This is the we have to find out that the covalent bond, how it is formed, how it is generated the covalent bond. Follow this question: how many bond pairs are there? How many lone pairs are there? Yeah, just listen. Here, oxygen is a central element. So oxygen atomic number is 8. That is oxygen atomic number is 8. Electronic configuration of oxygen, that is 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. Here we are considered as a excited state. Last two shells. These two are the excited state. So we have to check it out how many electrons are there in the excited state. This is s orbital. Again, p orbital exists in three. That is a px orbital, py orbital, pz orbital. So here, how many electrons are there in the p orbital? 4. 1 electron, 2, 3, 4 electrons. Here s 2 electrons. So here, how many unpaired electrons are there? These two are the unpaired electrons. Means single electrons, unpaired electrons. Only single electrons are unpaired electrons involving bond formation. So whatever that is remaining, these two, this is we are calling as a lone pairs. Lone pairs does not involving bond formation. So number of lone pairs are two. These two does not involving bond formation. Only unpaired electrons involving bond formation. So that we wrote oxygen electrons, one electron here, another electron here. These two electrons we wrote like this, one electron. Similarly, that hydrogen is atomic number is 1, electronic configuration is 1s1. We wrote here only one electron. In excited state here one electron here, because of hydrogens are 2, so here one electron. So this electron and this electron sharing of electron, this is form a one bond, this is also form a another bond. Again, remaining whatever that these two lone pairs, we should write down like this: one lone pair here, one lone pair here. Then final structure is O, H, then H, then here one lone pair, this is one lone pair. This is you have to write down. This is a V-shaped structure. V-shaped structure. Are you understood? Yes, Sujana. Any doubt? Saishri, understood? So this you have to write down. Don't write down the straight manner like this HOH, because this electrons and this electrons repulsions are possible. So that this is not possible. Always V-shape. Yes, another question. You have to solve this question. That is C2H2. What is this? Acetylene. Acetylene. Solve this question. So find out how many bond pairs, how many lone pairs. Then how many sigma bonds and how many pi bonds? Yeah. So listen, carbon, that is atomic number is 6. That electronic configuration 1s2, 2s2, 2p2. This is the excited state now. So here 2 electrons. Here this is one electron, two. So here again in excited state, this electron jump to here in excited state. So that here one electron remaining, these all orbital having one electron. Here unpaired electrons are 4 unpaired electrons. So we wrote here one electron, two electron, three, again one electron here. Similarly here one electron, two electron, three electron, one electron here. Anyway, that hydrogen has only, that is a hydrogen atomic number is 1, that is 1s1, which has only one electron. Here electron, here also electron. So that in this case, this electron form a bond, here form a bond, this electron, again this one, again this one. So here, this is whatever that bottom of the bonds, these three are the sigma bonds. Sigma bonds are three sigma bonds, 1, 2, 3. These two pi upper, these two upper, this is a number of pi bonds are, two pi bonds. Here, three sigma bonds, two pi bonds. Here, number of lone pairs are 0. Here there is no lone pairs. So sigma bonds 3, pi bonds 2. This is the question.